right, so number one, uniform means everything has the exact same probability. Okay, we are starting at 63 and ending at 90. So you need to make sure, however you set it up, you are attempting some kind of scale here. So maybe I'm going to start my graph. You don't necessarily have to start at 0, but if I start at 60, if you start at 63 and then 90, and since it's uniform, no matter where you are at, the probability has to be the same. So we know the total probability is what? 1. And so think about like the area represents your probability. Area is length times width. So we have to figure out what this number is. So essentially we know the length times the width of this rectangle has to equal 1. What's the length? How far is it from 63 to 90? So the width has to be 1 over 27. So that's where that probability came into play. Does that make sense? So B, the probability has that you have a temperature above 68. So 68 is here. If we went above that, we're essentially just finding the area of this rectangle. So the length of it, how far is it from 68 to 90? So 90 minus 68 is 22, times the height of that rectangle is 1 over 27. So you get 22 over 27, or 0.8148. If we look at C, we want the probability that you are between 70 and 77. So here's 70, 77. So we're finding the area of that. So how far is it from 70 to 77? 7 times the probability, the height, is 1 over 27. So we get 7 over 27, or 0.259. So uniform is the same probability throughout. Does that make sense to everyone? Number 5. So this is just a notation thing. So when we have Z alpha notation, alpha means this number is area to the right. So we talked about when we did it how it was kind of the opposite of how our normal table is set up. So we're talking about a curve where 34% of my area is to the right. So if I looked at it, this is an area of 0.34. You have to figure out what the Z is down here on your normal curve. So look at your normal table. Look at our formula sheet. If you look at the top of the normal distribution, it tells us this table is giving us area to the left. So how do I find my area to the left? So it's just like 1 minus 0.34 tells me I'm going to be looking for So we go inside the table because 0.66 is the area. So you are finding as close as we can get to 0.66. So we have a 0.6591 and a 0.6628. So 6591 is closer, and that is at 0.41. So we found the Z value, so that 34% of the area is to the right of that number. Is that okay? Number 6. In 2008, the average ACT science score was 20.8 with a standard deviation of 4.6. So the average, like a mean, 20.8. My standard deviation, 4.6. I guess I should probably call that. It's talking about the population, not a sample. Assume the scores are normally distributed. So we know our criteria is good, it's normal. Find the probability that a student has a score of at least 25. So we want the probability that our score at least means greater than or equal to 25. What do we have to do? Z-score. If we want to look it up on the table, we need our Z. Z is our value minus the mean divided by standard deviation. So 25 minus 20.8 divided by 4.6. So we are finding probability that Z is greater than 0.91. How do we do greater than from our normal table? 1 minus, because the table gives us less than. So then you go to your table, the Z is 0.91, and the probability is 0.8186. So if we subtract those, we get 0.181. B, we need the probability that our score is between 20 and 26. So what do we have to do? So if we're at 20 minus the mean, divided by the standard deviation, gave us 0.17. And for 26, minus the mean, divided by standard deviation, we get 1.13. So we are finding the probability that Z is between this. To do that, we have to subtract the probabilities. The bigger one has to come first, so we look up the probability for 1.13. So from my table, that is 0.8708 minus negative 0.17, 0.4325. And subtract those, and we get 8. Doing okay so far? If we look at C, we want the probabilities, we have a score less than 16. So again, get our Z. Z is our value minus the mean divided by standard deviation. So we get negative 1.04. So we find the probability that Z is less than negative 1.04. Okay, less than is the number given on our table. So we just look up negative 1.04, we get 0.1492. So change them to Z's. Less than is the number from the table. Greater than, you do 1 minus. And if it's between, you have to subtract the probabilities. Is that okay? Number 7. The long-term weather record for New York State. Annual precipitation has a mean of 39.67 inches and standard deviation of 4.38. If this is a normal distribution, find the probability of the following. So we get to assume it's normal. More than, so find the probability that our value is more than 50. So what do? Z-score. Z is our value minus the mean divided by standard deviation. So that is 2.36. Which is find the probability that Z is greater than 2.36. How do we do greater than? So 1 minus, and then we look up 2.36 on our Z table, and that is 0.9909. So if we subtract those, we get 0.009. B. Between 42 and 48. So we get our Z's. R value minus the mean divided by standard deviation for both of them. And those turn out to be 0.53 and 1.90. So we find the probability that Z is between those. Okay, in between we subtract. You have to do the bigger probability minus the smaller one. So we need to look up the 1.90 first. So that's 0.9713. And then we look up the 0.53. So that's 0.7019. And subtract those. We get 0.26. Is that okay? So C, finding less than, so get our Z, our value, minus the mean, divided by standard deviation. Find probability that Z is less than negative 1.75. Less than is just a number on the table. So if we look that up, it is 0.0401. Right, so common theme here. Take it, if we can assume it's normal, or if they tell us it's normal, then we can use the mean and standard deviation to get our Z value, and then look up our probabilities from the table. Let's look at 8. Are we good with A through C in problem 8? Just part D. So this one, we have the probability that the sample mean. So this is actually related, like question A is kind of on its own because it was just probability of one battery, so it's just your Z and like normal. B through D are talking about the sampling distribution of the sample mean. So in part B, you found the mean of the sample to be 90 and the standard deviation of that sample to be the beginning standard deviation, which was 35, divided by the square root of n. And I think I may have kept more decimal places on my answer keys, so there's a chance that you guys might have had a slightly different answer due to rounding. 7, that's probably why. 0.797. So did you guys keep it like this or did you round it up? So either one's okay, just make sure, that decimal can change things just slightly, so just make sure you're writing down what you're using, so I know. So either of those is fine. So then on part D, we are finding the probability that the sample mean, so sample is x bar, is less than 92. We need a z. Since this is x bar, we need to use the mean and standard deviation for x bar, not the original. So z is our value minus our mean divided by the standard deviation. So if you use 0.068, we get 1.18. So we're finding the probability that z is less than 0.18. Less than is the number from the table. So if we look up 0.18, we get 0.571. Are we good on D? Number 10. It tells us approximately 22.4% of adults are smokers. A random sample of 300 adults is obtained. Describe the sampling distribution of p-hat. Anytime I ask you to describe the sampling distribution, I want the criteria, the mean, and the standard deviation for that variable. If we have p-hat, what is the criteria?
Less than 5% of the population,
Mm-hmm.
and 10 times p times 1 minus p greater than 30.
Mm-hmm. Greater than 10. 30 is when we're dealing with x bar. All right, so in here was 300. Our p, we use the proportion, p-hats here, the proportion given in the problem, which was the 0.224. 1 minus 0.224. And is that bigger than 10? Yeah, so that's good. Second, would 300 be less than 5% of all adults? Yes. Right, the mean. If you're not sure, look on your formula sheet. Everything is here. So if we're talking about p-hat, okay, so it's under chapter 8, the right-hand side. The mean of p-hat is just p, our beginning proportion, 0.224, the one given in the problem. Standard deviation is the square root of our proportion times 1 minus our proportion over part n is 300. And we get 0.0241. So that's what I want when I ask you to describe. So B, in a random sample of 300, what's the probability that at least 50 are smokers? I'm talking about p-hats in this problem because I don't have anything about sample means. So we need the p-hat. If we're talking about 50 out of the 300, 50 over 300 is, so we are finding the probability at least, so greater than or equal to 0.1667. So now it's like the others. We need to get our z. Since our variable is p-hat, we have to use the mean and standard deviation for p hat. So z is our value minus the mean divided by the standard deviation. We get a negative 2.38. So we need probability z is greater than negative 2.38. Greater than is 1 minus. And we look up on our table. Negative 2.38. 0087. And that gives us 0.9913. C, would it be unusual if 18% or less were smokers? So a percent is like our proportion. We're finding basically the probability that the proportion is less than or equal to 0.18. So we get our z, so our value minus the mean divided by standard deviation. And we get negative 1.83. So the probability that z is less than negative 1.83. Less than is what our table tells us, so we look up negative 1.83. It's 0.0336. So is that unusual? Yes. What's the cutoff for unusual? Any other questions about problem 10? 11. So part A, we're describing the sampling distribution for p hat, so you check your criteria. N times p times 1 minus p has to be greater than or equal to 10. Check our sample is less than 5% of the population, so we're good there. You guys found the mean to be, not x bar, p hat. The proportion given in the problem, which was 0.63. And the standard deviation is your square root of p times 1 minus p over n. You get 0.0341. So we're good with part A. So part B, we want the probability of obtaining x equals 191 or more. So we have to get that into the p hat, and I gave you the hint and gave it to you anyway, but p hat is x over n. So if you divide those, that's where I got the 0.705. So find the probability that p hat greater than 0.705. So turn into a z. Since our variable is p hat, we need the mean and standard deviation for p hat, not the original ones in the problem. So our value minus our mean divided by our standard deviation. And if we do that, we get 2.199, so 2.20. So find probability z is greater than 2.20. For greater than, we do 1 minus. Look up your probability from the table, 2.20, 0.9861, and we get 0.013. Part C. Probability of 121 or fewer. So we need p hat. P hat is x over n. So p hat is always going to be a proportion. So either a percent or a decimal between 0 and 1. If I'm giving you that original number, you have to find your proportion. We find probability of less than this, or that many or fewer, so less than or equal to. So again, get our z. R value minus the mean divided by standard deviation. Is it feeling repetitive yet?
Yep.
It's a good sign. We're getting ready. So we should get a negative 0.73. So we're finding the probability that z is less than or equal to a negative 0.73. So we'll look up negative 0.73 and it's 0.2326. So basically you have to know your variable. Am I talking about just a regular x? Am I talking about a p hat or an x bar? Once you have the mean and standard deviation for that variable, it's all the same. Get your z, find your probabilities. So that's really all the chapters 7 and 8 stuff. Are we good on all of it? So then chapter 9 was when we got into like our confidence intervals. So let's take a look at some of those. You know that some of them we do on the calculator, some I've asked you to do by hand. Make sure you can do either way. So on a test, I probably ask you to try one by hand. And then after you've done one by hand, you can do the calculator. Unless you really like to do it by hand, you'd be free to do every problem by hand if you want. But. So number 12, we need a 98% confidence interval for the population proportion. All right, when in doubt, you can go to your formula sheet. We have confidence interval for the proportion. So that is our p. So if you look at your formula sheet, that's p hat plus or minus z alpha over 2 times the square root of p hat 1 minus p hat over n. So we need all of those components. The p hat is x over n. So x was 80, n was 200. We get 0.4. Z alpha over 2. Okay, some of those are on your formula sheet, some are not. So if you need to, think about it. 98% is in the middle. So that means there's 1% on either end. Okay. Z alpha, area to the right is 1%, so to look it up in the table, you have to do the area to the left. So you are looking in your table as close as you can get to 0.99. So if the area is 0.99, tell me the z that matches it. And the closest we get is to 0.33. That is 0.9901. 98% is one that's given on the bottom of the sheet too, so you could use either. All right, and then we have our p hat. We know our n was 200. So we're ready to do our formula. 0.4 plus or minus 2.33 times the square root of 0.4, 1 minus 0.4 over 200. Okay, so we're going to get an interval, do the minus first. 0.24 minus 2.33 square root of 1 minus 0.4 200. And we get 0.3193. And if you type that in, you can just hit second enter and bring up the next one and change your minus to a plus. 4807. So we're 98% confident the value lies between those two numbers. All right, problem 14. School administrator wants to estimate the percentage of full-time college students who have credit card debt of $2,000 or more. What sample size should be obtained? Look at your formula sheet. Under chapter 9, we have confidence intervals on one column, the second column is sample size. There's two bullets. One bullet is when we're talking about our sample proportion, and one is when we're talking about the mean. If I'm looking at this one, it has on part A, the pilot study indicates percentage is 34%. Is this talking about a proportion or a mean? A proportion. Percents are always dealing with proportion. Okay, have two options if you look at that first bullet. The first formula, n equals p hat, 1 minus p hat, z alpha over 2 divided by the error squared. That says you use that where p hat is a prior estimate. The second one, 0.25 times z alpha over 2 divided by the error squared, is if there is no prior estimate. So in part A, do we have a prior estimate? Yes, that's what the p hat, the 0.34 is. So the p hat is 0.34. My z alpha over 2. Okay, so it is 94% confidence. Is that one given at the bottom of our table? No, so we have to be able to think about it. If 94% is in the middle, that has 6% left over, so 3 on each side. Table gives us area to the left, so we need to look up in the table when the area to the left, so that total area is 0.97. So inside your table, you want the closest you can get to 0.97. So that would be 0.9699. And the z that matches that is 1.88. Does everyone see where I got my z? And the error, it said we wanted to be within 2.5%, so 0.025. So we plug in 0.34, 1 minus 0.34, minus 1.88, divided by 0.025 squared. This is talking about my sample size. Can you have a decimal on this? Can I have a partial person? No. And you always have to round up, because if you round down, you wouldn't have enough. So we get 1268.99. So that tells me for this to work, I would have to have 1,269. Part B says, what if we don't have a prior estimate? So if we don't have a prior estimate, we're using this formula. Same z alpha over 2. Same error. So if we plug that in, we get 1413.76. So we'd have to have 1,414 people. Is that okay? So you guys are good on A and B. A is just from the table. B to the left, you just make your T negative. Part C, 96% confidence. So that means 96% is in the middle. So how much do we have left over? 0.02 on each end. We know we have 23 degrees of freedom. So if we look at our T distribution, 23 degrees of freedom. This one at the top, it gives you the area in the right. So my area in the right is 0.02. So you go to the 0.02 column down to 23 degrees of freedom, and we get 2.177. Is that okay? Problem 16. So we need the point estimate for the population proportion. So that's p hat, the margin of error, that's E, and X. For a confidence interval with a lower bound of 0.051, an upper bound of 0.074, and I'm telling you that N was 1,120. When you set up your confidence intervals, what's the thing in the middle? P hat. So to find your p hat, what do we need to do? Yep, average. Add them up. Divide by 2. So our p hat is 0.0625. So when we find a confidence interval, we take our center, p hat, and add or subtract some margin of error. So the error is how far you go in either direction. So these are the same, we just have to find one, and you get it by subtracting. So we could do the center minus the lower bound, or you could do the upper bound minus your center. And get 0.0115. And then x, how can we find x? We know that p hat is found by doing x over n. Our p hat was 0.0625, so that has to equal x over 1,120. So if you multiply that over, you get that x had to be 70. So we're just working backwards on those problems. Last one, problem 17. A survey asking 40 Americans, so again this 40, how many books they read per year found that the mean was 13.4, standard deviation 16.6. Construct and interpret a 99% confidence interval. Alright, so we are talking about x bar. Look at your formula sheet. If I'm talking about confidence intervals, we have a formula for p hat, we have a formula for x bar. So under our chapter 9. And the first bullet is your p hat, the second one is your x bar. So that's our formula. If you're doing that on the calculator, do you guys all know where to go? And this is the one where you have to tell it if you're using data or stats. So data would be if I gave you the original values and you put them in your L1. Stats is what we have here when I gave you the mean and standard deviation. So we have x bar, we have s, we have n, we need t alpha over 2. So we know we wanted a 99% confidence interval. So if 99% is in the middle, how much do we have left? 1% split over 2 ends is 0.005. So when you look it up on the table, your probability at the top is the 0.005. How many degrees of freedom do we have? 39, n minus 1. Remember, this table is a little limited, but this one is on here. So 39.005 gives us 2.708. So now we plug into our formula. 13.4 plus or minus 2.708 times 16.6 over the square root of 40. Do the minus one first. You get 6.2923. And when you do the plus, you get 20.5077. And so the interpretation is make sure you include a confidence level, so we are 99% confident. This was talking about the mean number of books. Is between these numbers. Are there